Okay, when I first read this problem, I saw Tn, and I thought they were talking about Taylor polynomials, but they weren't. After I looked at the his video, I noticed about the trapezoid rule. So I had to update my notes to reflect that, all right? I also think this would be an unsuitable question on an exam because it takes far more work, and plus, I'm going to say it really requires a computer algebra system to effectively answer the question, all right? But I want to just kind of read it to you, and hopefully you're reading through this as well. But it says the error in the trapezoid rule estimate will depend on how concave or convex f of x is on each of the intervals. So if f is concave up, I want to point out what I mean by that. Trapezoid rule is going to look like this over here. All right? That's what a trapezoid looks like. So it goes on and says if it's concave up, I'm going to say maybe on the interval it would look like this over here. The trapezoid rule will give an overestimate. Well, I can see that. And it goes on to say, let's put this over here. If it's concave down, I'll say on the interval, by the way, where the trapezoid's drawn. So it says if it's concave up, the trapezoid will give an overestimate on that interval. If it's concave down, the trapezoid rule will give an underestimate. Well, I can see that by drawing those pictures, by the way. Since the second derivative measures the concavity of a function, it is intuitively reasonable, well, that's a key word, that the error should be proportional to the second derivative. Here's the theorem regarding the error, all right? So the theorem over here is this error is related to this thing over here, okay? On the interval from A to B, by the way. So this is the problem. This is why I'd say it's really a bad exam question. It requires some work over here, all right? So let's keep reading it. It says let f be twice differentiable on the interval A to B. Y twice differentiable, I'm looking at concavity, where Tn is a trapezoid rule, where n is the number of intervals you're taking. They're going to be equal-sized intervals. We're taking n of them. And then this is number C on the open interval between A and B such that this would be the error. All right? Again, it's a lot of work to get there. All right? So what's the E going to be? The E is going to be this. What's the A going to be? Well, going back on it, the A is 1. That's where they're starting. And the B is 4. Let's go back to that. 1 to 4. All right, what's f of x? Let's go back to that. This is the f of x. We got that part over there. What I have to do second derivative? What I have to do that is see it over here. All right? Then I start plugging it in. I plug in the A. That's fairly easy. I plug in the the B minus A cubed. Pretty easy. 12n cubed. This is the tough part. That's tough. All right? The way you're going to do that is you're trying to find a maximum point. The maximum. The C is going to be some number on the interval between 1 and 4. To me, that requires a computer algebra system. I also want to point out in my notes here, I do provide a link. It's not here, but I decided to provide a link to me doing the SAGE, to showing that maximum SAGE can find it. And again, I did use SAGE, right? There'll be a link in the notes, by the way. And I found that C was this number over here. Then what do I have to do? I've got to plug it in. So, and again, I do it in SAGE for you. I plug it in here, and I get a number. What number did I get? I found when I solved that equation, and I used SAGE to do that, was roughly 63 point something. But I got to go up. So what's that going to be? 64. Thank you.